GATE 2016 Civil Engineering Set 2 Question 54. A motorist traveling at 100 km per hour on a highway needs to take the next exit, which has a speed limit of 50 km per hour. The section of the roadway before the ramp entry has a downgrade of 3% and coefficient of friction F is 0.35. In order to enter the ramp at the maximum allowable speed limit, the braking distance expressed in meters from the exit ramp is. The relevant NPTEL reference has been cited. Coming to the useful data, one needs to know about the braking distance of a car. This is a related concept to SSD. So, if a car is moving on a road with a speed of u kilometers per hour and then it wants to retard to a speed of v using an acceleration of a. So using the third equation of motion, that is v square equals u square plus 2as, where v is the final speed, u is the initial speed, a is the acceleration and s is the braking distance. We can obtain SP as v square minus u square divided by 2a. Here, since acceleration would be negative, to reduce the speed as the vehicle is retarding, a should be kept as a negative value, which would take care of v square minus u square being negative. In this case, we have been given the initial speed of the car as 100 km per hour. Converting this to meter per second using the conversion factor of 5 by 18, we would get 27.78 meters per second. The final speed the car needs to retard to has been given as 50 km per hour, which is the allowable speed limit on the exit ramp. So converting this to meter per second using 5 by 18, we would get 13.89 meters per second, which is our v value. So we know that the braking distance is given by v square minus u square divided by 2a. So substituting the values, here v is 13.89 whole square minus 27.78 whole square divided by 2 times the acceleration. So the acceleration would be negative, so substituting a minus sign here, since it is a downgrade where the speed was 100 km per hour initially and it should get reduced to 50 km per hour by the time the car reaches the down ramp. The gradient has been given as 3%. So the acceleration will be g times f minus the gradient. Gradient has been subtracted from f. This is because the gradient has a downgrade value and it will help in increasing the speed of the car rather than braking. So we should subtract that from the friction level of the road. F has been mentioned as 0.35 and the gradient level has been given as 3%, which we would take as 0.03. So substituting the values, we would get 9.81 into 0.35 minus 0.03. We would get 27.78 whole square minus 13.89 whole square divided by 19.62 into 0.32. This would give the final answer to be around 92.189 meters, which can be rounded off to 92.19 meters, which will be the braking distance of the car needed to decelerate from a speed of 100 km per hour to 50 km per hour. So in order to enter the ramp at the maximum allowable speed limit, the braking distance of the car was found out as 92.19 meters. The relevant NPTEL reference has been mentioned.